See here, in effect of temperature, the effect of temperature can be explained by comparing the real behavior of nitrogen gas and its ideal behavior at different temperature. As shown in diagram. Let's see this diagram. यहाँ पे हमने एक ग्राफ प्लॉट कर रखा है and this graph is basically PV versus P. We know for real ideal gas PV equals to nRT, or another way अगर हम n को constant रखें for fixed quantity of gas, R is constant and at fixed temperature PV is supposed to be constant. PV is supposed to be constant at any pressure. So if you change the pressure, if you increase the pressure, you can see these blue color dotted lines. Okay, that's the ideal gas. PV is constant. You can see it's a straight line. It is a straight line at different temperatures. Temperature T1, T2, T3, and T4. But when we plot a graph, okay, for the real gas, just saying, okay, there is a deviation. Here, can you see this? When the pressure is low, obviously high pressure पे तो वो अलग है ही, वो तो last topic में हमने पढ़ाई करनी है. But at low pressure, you can see there is deviation. Can you see this deviation? Okay, one more thing. Here, T4 is greater than T3, greater than T2, and greater than T1. This is highest temperature, T4, in out of this four, and T1 is lowest. But if you see that when the temperature is low, this is the deviation. ये actual होना चाहिए ideal, और ये actually है. ये होना चाहिए था ideal ये है, और ये actual. You can see इतना सारा deviation हो रहा है. Temperature थोड़ा बढ़ा तो deviation थोड़ा कम हो रहा है. So for different temperature there is deviation in certain range of pressure. There is deviation, and ये deviation change होता रहता है. But अगर आप temperature ज़्यादा रखते हो तो deviation सबसे कम. Deviation सबसे कम. But you can see there is deviation. Correct? As shown in the diagram, here and here, at different temperatures for N2, the values of PV and P are plotted. Okay, in the diagram, the dotted line indicates the ideal behavior of the gas. We have seen that. At the same temperature, it is clear from the diagram that the temperature increases. We know that T4 is the highest. The depth of the curved portion goes on decreasing. Hence, as temperature increases, you can see depth of the curved portion goes on decreasing. Correct or not? The deviation of real gas compared to the ideal gas behavior goes on decreasing, and at different temperature the curved portion becomes flat, becomes a straight line for the appreciable range of pressure. At such different temperature, nitrogen gas shows ideal behavior. अच्छा, ये temperature पे nitrogen ने ideal gas behavior दिखाया at this temperature. That's why that temperature is known as Boyle's temperature. Why? Because ये temperature पे Boyle's law obey करता है. नाइट्रोजन के लिए ये Boyle's temperature. For every different gas, Boyle's temperature is different. Okay? It is at this different temperature. It follows the Boyle's law. So this temperature of the gas is known as Boyle's temperature. Its value are different for the different gases. So for example, for nitrogen gas, Boyle's temperature is, please underline this, it is 332 Kelvin for the nitrogen Boyle's temperature, and 108 the emergency number is for hydrogen. बराबर है कि नहीं? बराबर समझ में आ रहा है आपको? नहीं समझ में आया आपको? ओके, कौन सा इमरजेंसी नंबर? एम्बुलेंस का नंबर है ना 108. Let's continue over here. Therefore, the conclusion is that it is said that at a low pressure पे वो ideal gas behavior दिखा रहा था. हमने देखा low pressure, जो pressure की effect देख रहे थे, at one pressure, जब low pressure पे दोनों एक दूसरे को cross over करते हैं. बराबर है कि नहीं? And at high temperature, real gas shows ideal behavior, and एंड लो टेम्परेचर एंड हाई प्रेशर पे रिमार्केबल डिफरेंस। इज इट फाइन? सो ये था हमारा इफेक्ट ऑफ प्रेशर।